20 of Algebra 1 with Mrs. Whybark. This week we will be learning about quadratic functions and parabolas. So far this year, we will now be learning about quadratic functions, which form beautiful parabolas. We see these frequently all around us. They are used in architecture and art, and even the very thrilling roller coasters. Perhaps one of the reasons we use them so often in the things that we construct is because we find them frequently in nature. They are part of the breathtaking rainbows that arc across the sky. They are also frequently formed by wind and water when it causes erosion. And they are even seen in the arc of a graceful dolphin. Taking notes using the Week 20 video notes. These are available both on Moodle and will be passed out in class.
Think about a nice fly ball in baseball. The ball follows a path that arcs up to a highest point, and then falls in a path that mirrors its rise into the air. That path is a U-shape that will be very important to us today as we graph quadratic relations. Look at the quadratic relation y is equal to x squared. How do we know that it's a quadratic relation?
The highest power of one of the variables is 2, and the other variable has a power of 1.
Yes, very good. The relations that we will graph today will all be quadratic.
Why would we want to graph these relations?
Quadratic relations are used in many applications in science, business, medicine, and even sports. By graphing the relations, we can answer important questions to help us solve problems. Let's graph y equals x squared. First, we need some points that are on the graph.
This is the first example on the first page of your video notes.
Well, if x equals -3, y would be -3 squared, or 9. So, -3, 9 is a point on the graph.
-2 squared is 4. So, -2, 4 is on the graph.
If x is -1, y is 1. Plot -1, 1.
0 squared is 0. Plot 0, 0.
If x
On your handout, I have provided a table of points. You should be filling out these points and following along as we go. You can also plot the points on the coordinate plane.
x is 1, y is 1. Plot 1, 1.
2 squared is 4. So, 2, 4 is on the graph.
If x equals 3, y would be 3 squared, or 9. So, 3, 9 is a point on the graph.
I think we have enough points now. There's a definite pattern here. Let's connect the dots.
Hey, you! I see the pattern too.
Hey, who, Ferd? Who are you talking to?
I'm talking about the pattern, the U-shape.
This U-shaped curve is called a parabola. This is just one example of a parabola, but all the graphs of quadratic relations of two variables will look something like this one.
Notice that this particular parabola opens upward, and the lowest point on this parabola is called the minimum. Also notice that it is truly a U-shape and not a V, so be sure to connect the points using a nice smooth curve and not the straight lines of a V-shape. This is what the first part of your video notes should look like when completed. If needed, take a moment to pause and catch up.
Let's describe this parabola. What are some things that you notice about the parabola?
It has a bottom.
I beg your pardon.
He means it has a lowest point, the point where the parabola turns.
The point where the parabola turns is called the vertex. For this parabola, the vertex is the point 0, 0.
Let's use the letter V to represent the vertex.
V as in vertex? That makes sense.
Is this relation a function?
Yes.
How can you tell?
Because this parabola passes the vertical line test for functions.
That's right. This relation is a function. Every vertical line through this parabola intersects the parabola in only one point.
I noticed how pretty the parabola was.
What do you mean pretty?
Well, if you drew a vertical line through the vertex, that line would act like a mirror. One side of the parabola is a mirror image of the other side.
Yes, the parabola is symmetrical. And that vertical line through the vertex is called the axis of symmetry.
Now let's graph the equation y is equal to the opposite of x squared.
Well, if x equals -3, y would be the opposite of -3 squared.
This is the example on the second part of your video notes. I have also included a table for you to fill in the point values and follow along as they graph this equation.
Or -9. So, -3, -9 is a point on the parabola.
-2 squared is 4. The opposite of 4 is -4. So, -2, -4 is on the parabola.
Hey, this is kind of like the last parabola, except now all the y coordinates are negative. So, plot -1, -1, 0, 0, 1, -1, 2, -4, 3, -9.
This parabola opens downward, and its highest point, which happens to be the vertex 0, 0, is referred to as a maximum.
Whoa! It's the first parabola flipped over. That's cool.
Good observation, Ferd. How are these two parabolas similar, and how are they different?
They both have the same axis of symmetry and the same vertex.
They're both functions.
The vertex is the minimum for y equals x squared, and the maximum for y equals the opposite of x squared.
This is what the second part of your notes should look like when completed.
Now that you know what a parabola is, we're going to graph quadratic relations that are written in standard form. The standard form for a quadratic relation whose graph opens either up or down is y is equal to ax squared plus bx plus c. A cannot be equal to 0, but b and c may be equal to 0.
Why are you doing this to us? Standard form? A, B, C? A not equal to 0? Why do you have to make it so complicated?
Actually, it's going to be easier to draw the parabola if we use standard form. Let's see how it works.
Let's graph the equation y minus 20 is equal to x squared minus 8x.
That's not in standard form.
Well, then put it in standard form.
Just add 20 to both sides.
Now the equation is in standard form. Y is equal to x squared minus 8x plus 20.
What are a, b, and c?
Why do we have to do this?
We'll see soon enough.
A equals 1, B equals -8, C equals 20.
Now we'll see why standard form is so useful. For an equation in standard form, y is equal to ax squared plus bx plus c. The axis of symmetry for the graph is given by the equation x is equal to the opposite of b divided by the quantity 2a.
Wait!
Notice that a simply represents the coefficient in front of the squared term. In this case, we have just 1x squared, so a is 1. b is always the coefficient in front of the x that is not squared, and c is always the constant, so it is the term that does not contain a variable. These terms could be written in any order, so it's important not to remember that a comes first, for example, but to remember that a is always the coefficient of the squared term. This becomes very important when you plug in b and a in order to find the axis of symmetry.
Where'd that come from? Is that some kind of math magic?
Even though mathematics is magical, I didn't use mathematical magic. I'll explain where the equation for the axis of symmetry came from in another lesson. But for now, let's use this equation. You'll see that it works.
The axis of symmetry is given by the equation x is equal to the opposite of -8 divided by the quantity 2 times 1. X is equal to 8 divided by 2, or 4.
So, the axis of symmetry is given by x is equal to 4.
So we can see that the axis of symmetry is the vertical line, x is equal to 4.
Hey, we can find the coordinates of the vertex now.
Notice that the axis of symmetry is a vertical line. Therefore, the equation of the line always starts with x equals. Now that we have found this axis of symmetry, you can draw this on the coordinate plane on the fourth part of your notes.
Ow!
The axis of symmetry goes through the vertex. So, the x-coordinate of the vertex is 4.
What's the y-coordinate of the vertex?
When x equals 4, y equals 4 squared minus 8 times 4 plus 20.
So, y equals 16 minus 32 plus 20. Y equals 4. The vertex is the point 4, 4.
It seems to me that if we know where the vertex is, the rest is pretty easy because the parabola is symmetrical.
You were paying attention, Roxy. Let's find some more points on the parabola.
Let x equal 6. When x equals 6, y equals 6 squared minus 8 times 6 plus 20.
That means y is equal to 36 minus 48 plus 20. Y equals 8.
The point 6, 8 is on the graph.
Students will often ask at this point, why is x 6? The truth is, you can let x be any number you want and then generate a y value. Because we want to find points that are easy to graph, I typically choose values for x that are close to the vertex. Since our vertex is at x is 4, x equals 6 is not too far away. So we're likely to get a point that will fit on our graph paper. But really, you can let x be any number that you want.
We know that the vertex is 4, 4, and that the point 6, 8 is on the parabola. How can we find another point on the parabola?
We can use the fact that the parabola is symmetrical.
That's right, Lizzie. Show us what you mean.
The point 6, 8 is 2 units to the right of the vertex and 4 units above it. Because the parabola is symmetrical with respect to the vertical line through the vertex, there is another point on the parabola that is 2 units to the left of the vertex and 4 units above it. The point 2, 8 is also on the parabola.
Great work. Now let's find 2 more points.
Let x equal 3. When x equals 3, y equals 3 squared minus 8 times 3 plus 20.
That means y is equal to 9 minus 24 plus 20. Y equals 5. The point 3, 5 is on the parabola.
Once we know that the point 3, 5 is on the parabola, we can use symmetry to find another point.
The point 55 is on the parabola. This new point 55 is the image of the point 35 reflected over the axis of symmetry.
The parabola goes through our points. Notice that it opens upward.
In review, the first step to graphing this parabola was to find the axis of symmetry. The second step was to then find the vertex by plugging in the x value for the axis of symmetry into the original equation. Step 3 was all about finding more points. They generated 2 different points and then found their mirror images. The last step, step 4, is drawing the actual parabola. And just always remember that it should be a smooth U-shaped curve and not a V-shape. This is what the third page of your completed notes should look like. The actual graph for example 3 will be included on the next page. Please take a moment to jot down all of this level of detail.
In question 1 of Guided Practice Set 1, find the equation of the axis of symmetry for the graph of the equation y is equal to the opposite of x squared plus 6x minus 10.
In this video, they're going to refer to this equation as having 4 different problems, but actually this is simply example number 4 in the last part of your video notes.
The equation is already in standard form for a parabola that opens up or down. A equals -1, B equals 6, and C equals -10.
The equation of the axis of symmetry is x equals the opposite of b divided by the quantity 2a. X equals -6 divided by the quantity 2 times -1, or -6 divided by -2.
The equation of the axis of symmetry is x equals 3.
The graph of the axis of symmetry is a vertical line through 3, 0.
At this point, you can draw the vertical line x equals 3 on the coordinate plane. This is the axis of symmetry for this particular parabola.
The equation of the axis of symmetry of the parabola is x equals 3. We found that in problem 1.
The vertex is a point on the axis of symmetry, so the x-coordinate of the vertex is 3.
To find the y-coordinate of the vertex, substitute 3 for x in the equation of the parabola and solve for y. Y is equal to the opposite of 3 squared plus 6 times 3 minus 10, or -9 plus 18 minus 10. The y-coordinate of the vertex is -1. The vertex is 3, -1.
Take a moment and graph this vertex on the coordinate plane.
In question 3 of Guided Practice Set 1, find and plot 4 other points on the graph of y is equal to the opposite of x squared plus 6x minus 10.
When x is equal to 1, y is equal to the opposite of 1 squared plus 6 times 1 minus 10, or -5.
Notice that they plugged in 1 for x. Because our equation has the opposite of x squared, first you square the 1, 1 squared is 1, and then you take the opposite. So this becomes -1. Plus 6 times 1 is 6, with a minus 10 at the end.
So 1 -5 is a point on the parabola. By symmetry, 5 -5 is also a point on the parabola. When x is equal to 0, y is equal to the opposite of 0 squared plus 6 times 0 minus 10, or -10. So 0, -10 is a point on the parabola. By symmetry, 6 -10 is also a point on the parabola.
Draw the parabola through the points 3, -1, 1, -5, 5, -5, 0, -10, and 6, negative 10.
Once again, notice that they have drawn a nice smooth U-curve and not a V to represent this parabola. This is what the final page of your notes should look like when completed. Please be sure to include all the steps in graphing a parabola. The first was to find the axis of symmetry. The second step is to identify the vertex. The third step was to identify two more points and their mirror points. And lastly, to draw the line on the coordinate plane. Good boy, what a nice parabola you've made. Thank you for watching this Whybark production.